the last learning objective of the semester. Yay! Whoop, 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 whoop. All right. Is to describe the purpose of an acid-base indicator. So before we do this, I like to talk about titrations because this is where you use an acid-base indicator, is when you titrate a solution. Also, probably one of the most important lab techniques in chemistry. So titration is the method for quantifying the amount of acid or base in a solution. This uses a burette and an Erlenmeyer flask, usually. And then there's two parts. You have the titrant and the analyte. The titrant has a known concentration, whereas the analyte has an unknown concentration. The volume of titrant used is used to determine the concentration of the analyte. So in the setup for this, because you are going to have to perform a titration, you have the burette with your analyte in it, or titrant in it, titrant. So you have your burette with your titrant inside, and then you have the Erlenmeyer flask with your analyte inside. And you add your titrant to your analyte. Now, the equivalence point. So, we have a couple of things that we kind of talk about with a titration. You have the equivalence point. So, the equivalence point in a titration is where the moles of the acid are equal to the moles of the base. This is where you completely neutralized the solution. And this is the point that you can determine. So, we're neutralized. Neutralized. So we are neutralized at this point. And from this point is where you can determine the concentration of the analyte. Now, this requires solution stoichiometry. So again, like when we went back in the last chapter, we talked about solution stoich. So this is another way that you can use solution stoichiometry in this case. So again, where you have a volume and a concentration, multiply them together, divide by your opposite thing, right? So in this case, I have 10 milliliters of hydrochloric acid solution, and it's got an unknown concentration. Don't know the concentration. I have 12.54 milliliters of 0.1 molar NaOH solution to reach the equivalence point. What concentration of unknown hydrochloric acid solution? Now, here's a really cool thing about neutralizations. Number one, you always have to have a balanced chemical equation. But with neutralizations, to where you have your hydroxide OH minus and your H plus, you can get your mole ratio without having to balance the equation. So if I have hydrochloric acid, which is HCl, and I have sodium hydroxide, which is NaOH. Well, I have one H plus to one OH minus. This means that my mole ratio is 1 to 1. Okay. Now, if you had sulfuric acid, H2SO4, and NaOH, well, this is 2, this is 1, so this would be a 1 to 2 mole ratio, 1 acid to 2 base. Okay. So that's just how you can get your mole ratio really quickly without actually balancing the full equation. Usually I don't think I ask you anything that you have to have the balanced chemical equation for. If I do, then I'm going to give you the equation. You just have to balance it. So I have 10.00 milliliters of HCl. Okay. I don't know of a question mark molarity. And then I also have 12.00 12.54 milliliters of a 0.100 molar NaOH. Okay, again, I'm going to multiply these guys together. Okay, and then I need to find my concentration, my molarity of HCl. So 12.54 milliliters. Since these guys are both in milliliters, I don't have to convert out of milliliters. And then I'm going to multiply that by 0.100 moles of NaOH per 1 liter. So liters are canceling out. I'm still in milli. Times, I have to go through my mole ratio. So I've got a volume and a concentration, and I need to go through my mole ratio. So volume, concentration, and then this is going to be my mole ratio. Well, since I have one hydroxide to one H plus, it's 1 to 1. So it's 1 mole of NaOH to 1 mole HCl. Okay. Now, crazy part about this volume molarity is moles per liter, so moles per volume. So I need to divide by my volume here. So I'm just going to take 1 on the top. That's absolutely fine. And then I'm going to take 10.00 milliliters on the bottom. Now, I can't cancel out my moles, but I can cancel out my milli here. So 12.54 times 0.1 divided by 10 would give me my concentration of my HCl. So 12.54 times 0.1 divided by 10 gives me 0.125. And let's look at sig figs. So I got 4 sig figs, 4 sig figs, 3 sig figs. So I need 3 sig figs in my answer. So 0.125 molar HCl. I'm done with that problem. So in a neutralization reaction, there's no visual to signify the end of the reaction. So I've got a clear solution of acid and a clear solution of base. I cannot see that actually occurring. So in a neutralization reaction, there is no visual to signify the end of the reaction, since we mix 2 colorless solutions to form another colorless solution. So this is why an indicator is used to signify the end point of a neutralization reaction. Note, the endpoint does not mean the equivalence point. So the endpoint does not mean the equivalence point, but it is close enough. So what is an indicator? So an indicator is a dye whose color depends on the acidity of a solution. So a lot of times we use organic dyes, and they have 2 different colors, one in base, one in acid. Just depends on what it is. There are several different indicators that can be used. You have litmus, phenolphthalein, methyl orange, are all really good indicators to use. So an indicator is a dye whose color depends on the acidity. We use them in titrations. Titration is a neutralization reaction in which you have an acid or a base that you do not know the concentration of. Helps you to quantify the concentration of an acid or base solution. Again, you can't see any indication of an acid-base neutralization occurring just because of the fact that you mix 2 clear colorless liquids and you form a clear colorless liquid. So you can't see that unless you have an indicator, and the indicator is used to determine the endpoint, not the equivalence point. So this was the last learning objective for the semester, which was Unit 7, learning objective 15, which was to describe the purpose of an acid-base indicator. You will also be performing a titration as well. So this was important for knowing what a titration is and actually being able to perform a titration. Peace, guys. It's been a fun semester.